Hello students, today we are going to discuss chapter number 9 carbon, topic carbon dioxide. So as everybody knows that carbon dioxide is present in the air in 0.03% and its amount is greater in cities because of pollution as compared to countryside or villages. It is used by plants for photosynthesis. It is also used by and it is given out by plants and also animals during respiration. Then it is present in the form of carbonates in minerals like limestone or marble, which is calcium carbonate, dolomite, magnesium carbonate, MgCO3.CaCO3. The complete formula is MgCO3.CaCO3, and calamine, zinc carbonate. Calamine is present in powder. Okay, calamine is present in talcum powder. So these are the combined states of carbon. Now, how can we obtain carbon dioxide? Carbon dioxide is formed in the following reactions. First is burning of carbon and carbon-based product. Carbon dioxide is formed when carbon is burned in excess of oxygen to give carbon dioxide. So if carbon is burned in proper supply, excess here means when carbon is burned in proper supply of oxygen, then carbon dioxide gas is evolved. But on the other hand, if the supply of oxygen is insufficient, if it is less, if it is insufficient, then instead of carbon dioxide, carbon monoxide gas is formed, and carbon monoxide gas is poisonous in nature. Okay, so then carbon based. Now we have studied that burning of carbon dioxide is formed either by burning carbon or by using carbon based fuels. So carbon based fuels means the fuels which have carbon. So CNG, full form is important, compressed natural gas. The main constituent of CNG is methane, formula is CH4. LPG, which is liquefied petroleum gas, which is mainly main component of LPG is butane. So you should remember that CNG main component is methane and LPG the main component is butane. Both of them burn smoothly to form carbon dioxide and evolve water. So you can see CH4, which is methane, which is present in CNG. It will give on burning in carbon, which will give carbon dioxide and water, and butane, which is a next member of the methane family only. First member of this family is hydrocarbon family is methane, then butane. So it burns in more oxygen, 13 O2 to gives 8 CO2 and 10 H2O. So fuels like petrol and kerosene and diesel are mixture of hydrocarbons. Hydrocarbons are those organic compounds which have hydrogen and carbon together. Hydrocarbons are those compounds which have hydrogen and carbon in combined state. So when we talk about petroleum, kerosene, and diesel, then different types of hydrocarbons are present in them. So ultimately, if there are lots of hydrocarbons, so they will have large number of carbon atoms, and all of them will burn to form carbon dioxide and water. So whenever hydrocarbons are burned, hydrocarbons, as you can see, CH4 is hydrogen and carbon. Hydrocarbon, as the name suggests, it has hydrogen and carbon. So CH4 has hydrogen and carbon. Ca4H10 also has hydrogen and carbon. So whenever there is burning of any hydrocarbon, then carbon dioxide and water is evolved for sure. Next method of preparation of carbon dioxide is thermal decomposition of carbonates. As the word suggests, thermal decomposition. Thermal means heat and decomposition means when larger molecules break down into simpler one, or you can say when there is one reactant but two products. So thermal decomposition means decomposition carried out by providing heat energy. So, thermal decomposition of metals like magnesium carbonate, calcium carbonate, when you heat them, they will give magnesium oxide, carbon dioxide, calcium oxide, and carbon dioxide. So, thermal decomposition of carbonate means decomposition which is carried out by heating. Next method of formation of carbon dioxide is action of an acid on carbonate or hydrogen carbonate. So whenever a carbonate or hydrogen carbonate comes in contact with acid, always there is evolution of carbon dioxide. This process is effervescence, which we have discussed in seventh class also. Effervescence is a process in which gas bubbles are seen with hissing sound. So hissing sound or the gas bubble are because of presence of carbon dioxide only. So you can see that if any carbonate or bicarbonate, or also known as hydrogen carbonate, like Na2CO3 is carbonate, and NaHCO3 is known as sodium hydrogen carbonate. Also, it can be said as sodium bicarbonate. So whenever they comes in contact with any acid, as soon as they come in contact with acid, evolution of carbon dioxide gas takes place. This effervescence, or this one can you can do at your home also. If you take baking soda and you put lemon juice over it, then you will see some amount of brisk effervescence, because anything which have carbonate, and if it is coming in contact with acid, it will always evolve carbon dioxide gas. The next method of formation of carbon dioxide is fermentation of sugar. Carbon dioxide is evolved during fermentation of sugar in the presence of yeast. Fermentation is the process in which, in the presence of yeast under anaerobic conditions, the alcohol is prepared. Okay, so carbon dioxide is evolved during fermentation of sugar in the presence of yeast, a process in which alcohol is formed. And this is how ethanol and alcohol is manufactured from molasses. Molasses is obtained from sugarcane, sugar industry. So you can see C6H12O6. It is again from obtained from molasses by fermentation by the action of yeast. It gives ethanol, which is a kind of alcohol with the evolution of carbon dioxide gas. Okay, then next is laboratory preparation. These all methods are to prepare in these all methods which we have studied, they are used to prepare carbon dioxide in industries or wherever they are required. Laboratory preparation is always different because it can sometimes be costly, and but laboratory preparation and normal preparation difference is laboratory preparation are done in labs under specific conditions and not keeping in mind the expense. But if you set up an industry and you use expensive chemicals, and the production is, or the profit is less, then it is of no use. So methods can be different. So principle of laboratory preparation: carbon dioxide is prepared in laboratory by the action of dilute hydrochloric acid on marble, which is calcium carbonate. So you can see the equation: CaCO3 plus 2HCl gives CaCl2, CO2 and H2O. So okay, so this equation is the equation for laboratory preparation of oxygen. This you should remember. As the gas is heavier than air, the carbon dioxide gas is heavier than air, so it is always collected by the upward displacement of air. Okay, then now let us see the procedure. You have to take some marble chips in conical flask covered by water. We will look at the figure and then we will understand. You can look at this figure. Figure 9.12, you can see we have taken marble chips in a conical flask and covered by water. The flask is fitted. Now there is a thistle funnel over which the flask is fitted with a thistle funnel and a delivery tube which is bent at 90 degree. So in dilute HCl is poured through thistle funnel into the flask. Not we will pour dilute HCl drop by drop. Complete dilute HCl is not dropped together. So you can follow my cursor from this. This is thistle funnel. From here, this is thistle funnel. From here, it will go and reaction will take place, and then will carbon dioxide gas will travel through this bent tube which is placed at 90 degree, and it will be collected in this jar. Okay, dilute HCl is poured through thistle funnel into the flask. The yellow part which I have shown in uh, the screen is thistle funnel. A brisk reaction takes place. So as soon as a dilute HCl reacts with marble chips, a very fast reaction will take place. Gas is evolved it will displace the air inside the flask and the delivery tube first, and then collects in the gas jar. By underlying this, the method of collection of carbon dioxide is by upward displacement of air, because it is heavier than air. Now if you want to test whether the jar is completely filled with carbon dioxide or not, a lighted matchstick is brought near its mouth from time to time. When the flame gets extinguished, you know that carbon dioxide does not support burning. So when the flame get extinguished, then we will say that then the flame will get extinguished. Then we will say that the gas collected is carbon dioxide. The delivery tube is taken out of the jar and is closed by putting the lid in a place. Okay, now you could use sodium carbonate in place of marble chips, and but then we have to use dilute H2SO4 in place of dilute HCl. The reaction with marble is, however, more smooth. So next reaction, if you want to do the reaction with sodium carbonate and dilute HCl, then also it can be done. Now could we use H2SO4 with marble instead of, now see, the combination comes out to be calcium carbonate. It should react with HCl, and sodium carbonate, it should react with H2SO4. But if calcium carbonate, you are making it to react with H2SO4 instead of HCl. If instead of calcium carbonate, in calcium carbonate you are using H2SO4 instead of HCl, then the reaction will not continue because calcium sulfate will be formed, which is insoluble. The reaction will stop in the middle, as salt being insoluble will deposit on the chips, preventing the from coming in contact with acid. So as the reaction begins and as some amount of calcium sulfate is formed, it will form a layer over the other marble chips, above other calcium carbonate, and the acid will now no longer be in contact with calcium carbonate and the reaction will stop there only. So that's why with calcium carbonate we use HCl, and with sodium carbonate we use H2SO4. How about using H2SO4 with Na2CO3? So this is all right because salt Na2SO4 is formed, which is soluble. So when we use Na2CO3 and H2SO4, as you can see the original reaction, Na2SO4, this one Na2SO4 plus dilute H2SO4, Na2CO3 plus dilute H2SO4 if we are taking, then there is no problem in this combination because we get Na2SO4 sodium sulfate, which is soluble, and since it is soluble then reaction will not be hindered. The problem with calcium carbonate and sulfuric acid is that calcium sulfate, which is formed, it forms insoluble layer above the reaction mixture. Then does the action of dilute HCl on marble chips give pure carbon dioxide? No, the gas is contaminated with some amount of HCl as latter get volatile by evolution of CO2. The gas can be freed from HCl by vapors by passing it through small amount of water before collection. So the gas which we get in this laboratory preparation, carbon dioxide gas which we are getting in laboratory preparation, it is not very much pure. It has some amount of HCl impurities. So for removing that, we will pass the carbon dioxide gas through water. As you can see, impure CO2 is passed through water and then it is collected in another jar. So that we make sure that the gas is free from any kind of impurities. The next topic which we have to do is physical properties of carbon dioxide. It is colorless, it does not have any color. It has no odor, and it is heavier than air. At 1 atmospheric pressure, the gas directly solidifies at minus 780.5 degree. This is important. Solid carbon dioxide, solid is called dry ice as it sublimes at the temperature. It's vaporized without turning into liquid. So solid carbon dioxide, or also known as dry ice, is important. It is used as refrigerating material. Okay, and it has it vaporize without turning into liquid, so it is, that's why it is called dry ice. Otherwise ice, if it melts, then it will make the things wet. But since this are dry ice, it's directly changes to vapor state without being changed to liquid state, so it is called dry ice. It does not wet the things, and at minus 78.5 degrees Celsius it directly solidified, the carbon dioxide gas directly solidified. Under ordinary conditions, water dissolves in its own volume of gas, but under high pressure, gas is highly soluble in water. This fact is used for making fizzy drinks like Aquafizz or all these cold drinks, in that carbon dioxide generally is not soluble in liquid or in water, specifically in water. But if we apply a lot of pressure, then it becomes soluble. So in these fizzy drinks or soda bottles in cold drinks, same thing is done. A lot of pressure is applied, because of which the carbon dioxide gas gets mixed in the water. But when you open the any cold drink or any soda bottle, then what happens again, now the difference in the pressure occur and all the carbon dioxide gas evolves out. Okay, so this is basically which what is happening when it is, because it is under great pressure, it is filled in the bottles. Now chemical properties of carbon dioxide, we can see combustion means burning. It does not burn, neither it helps in burning. In fact, it is used to extinguish fire, to put off fire. So it is used in extinguishing a fire. Why it is used in extinguishing fire? Because it is heavier than air. वो air के ऊपर deposit हो जाएगा and it will cut the supply of oxygen. Okay, being heavier than air, it displaces air from the vicinity and fire gets extinguished. So oxygen supply is cut from the fire and hence the fire will put off. Okay, so we can easily understand this by following activity. You can look at this figure. In this activity, we have taken baking soda in glass A, okay, and some vinegar we have added to it, and by adding vinegar, baking soda to vinegar, carbon dioxide gas will be produced with effervescence. Now let effervescence subside means let effervescence finish. You can see in figure B. In figure A, you can see the bubbles. The bubbles shows that carbon dioxide is still being produced. And in figure B, you see there is no bubbles. It means the effervescence have finished. It has subsided. Now hold glass A almost horizontally above glass B for a short while, taking care that no liquid flows from A to B. Now hold glass B in a pouring mode means in now in glass A we have gas and we have transferred the gas to glass B. Okay, and now glass B has carbon dioxide gas, and now we have a candle which is burning. And if we tilt the glass B over the candle, then fire will put off. So this shows that glass B have carbon dioxide, and because of which it has extinguished the fire. So carbon dioxide gas can be used to extinguish fire. It reacts with metals like sodium, potassium, magnesium, and extract oxygen from CO2 when burnt in gas. Experiment we can see, take a glass jar of CO2 and introduce a burning piece of magnesium into the metal continues to burn in gas. As a result, white smoky scales of magnesium oxide are deposited on the inner walls of the jar. This magnesium, when it reacts with carbon dioxide, the magnesium oxide is formed along with formation of carbon, and carbon is shown by black color. In the reaction, some black color carbon particles are also formed, which can be seen more clearly if smoke scales of MgO are dissolved in dilute HCl. Then next is action on litmus. Litmus paper is used to test the acidity or the basicity of any solution. So aqueous solution of gas is weakly acidic and turns blue litmus wine red. So carbon dioxide nature is acidic. It is acidic oxide. Acidic nature of gas is generally tested by placing a moist blue litmus paper. If it turns red, then we will say the gas is carbon dioxide. Also, when carbon dioxide it reacts with water, it forms acid which is known as carbonic acid. This carbonic acid is only present in the cold drinks. Reaction with metal oxides. When carbon dioxide it reacts with metal oxides, and the carbon dioxide slowly react with metal oxides to form metal carbonates, which are salts. So Na2O plus CO2 gives Na2CO3, MgO plus CO2 gives MgCO3, and CaO plus CO2 gives CaCO3. Then the reaction with lime water. Lime water is the test for presence of carbon dioxide. If the lime water turns milky, then we can say carbon dioxide is present. So basically, the reaction of carbon dioxide with lime water is studied in three parts. First, lime water is calcium oxide. It reacts with carbon dioxide to form calcium carbonate, which cause milkiness. So milkiness in lime water is because of calcium carbonate, and water is involved. Now this milkiness will disappear when you add more carbon dioxide to it, because now calcium hydrogen carbonate is formed, which is soluble, and the milkiness will disappear. But the milkiness will reappear when the above mixture is boiled. This is because hydrogen carbonate on being heated decomposed to give again carbonate, and because of carbonate only the solution is milky in nature. So milkiness is basically because of calcium carbonate, but if you add a more carbon dioxide, then calcium hydrogen carbonate is formed, which is not milky. But if you heat calcium hydrogen carbonate, it will break down to give calcium carbonate, and again the solution will turn milky because of formation of calcium carbonate. Now let us see how carbon dioxide is related to environment. It is present in very less amount in the atmosphere, but if it is increasing, it cause various problems. The first use of carbon dioxide is in photosynthesis. Green plants prepare their food from the by taking carbon dioxide from the atmosphere by the first process of photosynthesis. Next is greenhouse effect. So during the day, sun rays enter the glass house and keep the plant warm, but traps green what is basically a greenhouse effect. But first we will see what is a glass house. A glass house is just generally kept in nursery, where small plants are kept which require a lot of heat. So in this glass house, the heat rays can enter the glass, but they cannot escape the glass. So same thing is happening in our environment. Carbon dioxide is acting as a glass house. It allows the heat energy, or you can say the sun's rays and its heat energy of the sun, to enter the earth atmosphere, but does not allow it to radiate back, and hence the heat is retained in the atmosphere, which increase the average temperature of the atmosphere, and because of which global warming is occurring. So carbon dioxide, which is present in earth atmosphere, it plays the same role as glass in the greenhouse. It traps the heat of the sun rays and keep radiating it back, so that warmth of the earth is retained. The sun rays heat the earth directly, also, but A large portion of rays are reflected back. So without the warmth produced by CO2 of the atmosphere, Earth would have been much colder than nights. Of course, it is very much essential for carbon dioxide to retain heat. Otherwise, during the daytime, we will have a lot of heat in the atmosphere, but at night it will be completely chilled. But because of the problem now is not of the carbon dioxide, but because of excess of it, a gas that traps heat in the environment and keeps the surrounding which warm is called greenhouse gas. So carbon dioxide is of course a greenhouse gas, and its effect is greenhouse effect. Thus CO2 is a greenhouse gas, and other such gases in our environment are mainly methane, which is emitted by cattle dung, fluorocarbons, which are used in fridges and air conditioner. Global warming, now we will see what happens. But if the carbon dioxide concentration increases, then the average temperature of the earth increase, and because of increase in average temperature, ice caps and glaciers will melt, and it can result in increase in sea levels. And finally there can be situations of flood or drastic climate changes which we are still facing. All this will happen due to rising Earth's average temperature, that is due to global warming. Afforestation means planting more and more trees can bring down the problem of global warming, because plants absorb carbon dioxide from the atmosphere and the balance is maintained. But the deforestation, which is happening actually now, deforestation means cutting the trees. Since it is on increase due to increased population, because of increase in population, more and more deforestation is occurring. It is creating a problem of more and more carbon dioxide in the atmosphere, and hence as more the carbon dioxide, more heat it will accumulate, it will retain more amount of heat, and hence what will happen basically, uh, the average temperature of the earth is increasing, which results to global warming. Now action on natural water. What happens with natural water? Natural water is slightly acidic to slightly alkaline. pH is 6.8 to 8.5, somehow between. It is measured with the help of pH meter or pH paper. Pure water is neutral, that is, it is neither acidic nor basic, 7.0. Acidic solution have pH less than 7, and basic solution have pH more than 7. So carbon dioxide, when it dissolves in water, it forms weak acid H2CO3. So gas tends to bring down the pH of water. Means it the carbon dioxide gas, it makes the water little bit acidic. But for drinking purpose, this slightly acidic water is better than alkaline. The acidic water pH is 6.5 is soft and palatable, but alkaline water is hard and unpalatable. Means we don't like to drink alkaline water, although we can have some amount of acidic. The pH inside our digestive system is also acidic. Our digestive system has it's HCl. During the digestion, HCl is released from the stomach. So our digestive system also has acidic pH. On the other hand, marine organisms, the organisms which live in water, they feel better in alkaline water as compared to acidic water. And it has been found that increasing proportion of dissolving CO2 is lowering the pH of seawater. This is posing a threat to marine life, because they want alkaline water, they want more pH. pH, if it is decreasing, it means the water is becoming acidic, so it is uncomfortable for them to survive. Now let us see what are the uses of CO2. It is used in industry for making metal carbonate, soda ash, etc. Then it is used in making urea, which is a fertilizer. It is used in making ethanol, which is an alcohol. It is used in fire extinguishers, and it is used in making cold drinks or soda water bottles. Now we come to our next topic, how a fire extinguisher works. So as you can see in the figure, there is a plunger and there is H2SO4, and then there is sodium carbonate and nozzle. So basically what is happening, whenever there is fire, the plunger is pressed, then what does it do? It release H2SO4, and sodium carbonate and H2SO4 will now come in contact with each other. Earlier they are not in contact with each other. H2SO4 is separate and sodium carbonate is separate. But if plunger is pressed, then H2SO4 comes in direct contact with sodium carbonate, and the reaction takes place instantly. Carbon dioxide gas is evolved. It will come out through the nozzle and it will extinguish the fire at the same time. So the red color cylinders which you see here and there, they are actually fire extinguishers. Don't consider that they are filled with CO2. They are never filled with CO2, but actually when you press the plunger, at the same time reaction is occurring, because the two chemicals now get mixed. Earlier they were separated, but now they get mixed and the reaction is occurring, and the carbon dioxide which is evolved, it's at the same time it comes out of the nozzle and it extinguish fire. So you can see the reaction which is taking place is sodium carbonate plus H2SO4 gives Na2SO4 H2O, and this CO2 which is evolved. Also, sodium hydrogen carbonate can be used, which with H2SO4, then it, in that case, water and carbon dioxide both will gush out, means both will be released out of the nozzle. A solution of sodium carbonate or sodium hydrogen carbonate is placed in fire extinguisher, a sealed bottle containing sulfuric acid. As you can see, sealed, it is not open from anywhere. In case of fire, the acid bottle is broken. How do it broke? By striking the plunger against a hard surface. The acid reacts with sodium carbonate or sodium hydrogen carbonate. Either sodium carbonate or sodium hydrogen carbonate, any of them can be filled, and carbon dioxide is formed. A mixture of water and carbon dioxide gushes out, means it moves out of the nozzle, which is directed towards the burning object. जो डायरेक्ट आप जो जल रहा है उसके ऊपर लगाते हैं. Carbon dioxide being heavier than air, what now, how do it extinguish fire? Earlier also I told you, since it is heavier than air, carbon dioxide will settle above the air and hence it will cut the supply of oxygen, because it will displace air and takes its place. A mixture of carbon dioxide being heavier than air surrounds the burning object and cuts off the supply of air. As a result, the fire is put out. So, since carbon dioxide is heavier than air and it does not helps in burning nor it supports combustion, it surrounds the object which is burning and cut the supply of air or oxygen, and hence fire gets stopped. So, fire extinguishers basically works on the principle of reaction of sodium carbonate and sulfuric acid, but sulfuric acid is kept in a sealed container which is broken by hitting a plunger to a hard surface, and when the two components get mixed, at the same time gas is produced and fire can be put out or put off. So for for now, we are ending it. So I think everybody should read the chapter from the book itself, and also you should watch the videos repeatedly. Please watch the video. Thank you so much. Have a nice day.